negative, you know, we sold less than we thought we would have, but that's okay. I'm going to copy this the rest of the way down, and I can see what I would have predicted at any given time using the linear equation. On the next month where I priced it at 300 and sold 103, my model would have suggested I would have sold almost 105. Okay, sometimes it'll be lower, sometimes it'll be higher, that's just what happens, okay? I want to do the exact same thing for the predictions had I used the power equation. So in other words, plug in each of those prices to X and see what Y would have been in each of those 12 months. So I'm going to go in here. It's Y equals AX raised to the B. So it's A, the constant coefficient, times X, the actual price of that month, raised to B, the exponent. So it's B22, and that's absolute reference, times B4 raised to the B23, and that was an absolute reference. So it's just taking the AX raised to the B, plugging in my actual 12 months worth of prices to get a prediction. So the power equation would have predicted that first month that I would have sold 50.8. Again, I sold 45, but it was a little closer, not a lot, but it was a little closer. It was further off from the next month than the linear was. I mean, that's going to happen. But let's now do the exponential. Remember, the exponential is Y equals AE raised to the BX. Okay? So A, being the constant over here, times E. Okay, there's where we need Excel's help. Okay? So E, in Excel, we use the EXP function, and then in parentheses put what we're raising the E to. Okay? And we were raising the E to the exponent times X, X being the price. Okay, so that's AE raised to the BX. Okay. The constant and the exponent coefficients before being the price. Okay, obviously this is month one, so it's the month one price, but I can see all the predictions that would have been made using the exponential. Prediction is great, but one of the things that we can do with prediction, if we're using predictions off of known, what historical values, is to come up with error so that we can actually see how much error there was in our prediction from the reality of what happened. And so I'm going to go over here. And in the first month, my error was, I'm going to put parentheses now, my actual demand, that's C4, minus what I would have predicted. Okay, that's the error, C4 minus E19. But the thing about error like that is that if you have very, very large numbers, they may have what look like large errors, and if you had small numbers, they may look like what has small errors, when in reality, these small ones might have been a greater percentage than these larger ones. So you never just want to look at error as the value itself. You've really got to take it as a percent. So we want to have the percent error. So I take what I did, which is the actual minus the prediction, and then I divide it by the actual. Okay? So in our case, that's C4 minus E19 in parentheses divided by C4. Okay? The actual minus the predicted divided by the actual will give me a number that can be compared across numbers that are big and numbers that are small, because it's a percentage. Okay? Now, I am going to want to copy this all the way down and all the way over. So any reference up here in C4, I want the 4 to change, okay? But I don't want the C's to change. So in both of those C4 references, put a $sign just in front of the C. Just in front of the C, but not in front of the 4. Okay. The E19 reference, if you think about it, what I want to have happen is I want it to change this way, I want it to change this way, I want it to change everywhere. So don't put an absolute reference at all on the E19. So here's my percent error. My percent error is a negative, basically 15%, okay? But I'm so sorry. Okay, I'll move a little bit. So my percent error is a negative 15%. But see, here's the problem. I'm going to look at the overall error for all 12 of them, for linear, power, exponential. And if I average it, which is what I'm going to do, and I see that average, and I had negative and positive numbers in there, I have no idea if I had little bitty negatives and little bitty positives, or if I had big negatives and big positives, and they all averaged out to about here. Okay, I'd have no idea. So if I'm going to average them, I've got to get rid of the direction. It's not going to be about the direction. I need to know the magnitude. Okay, I need to know, were my errors around 1, 2, 3%, or were they around 25, 30, 35%? Okay, and I've got to get rid of the direction to figure that out. So I need for this to be, and that's why you see this written up here like this, an absolute percent error. So I've got to take this error and put absolute around it so that it'll give me just the magnitude of the error, not the direction. Because my goal here is to figure out how much off was I. Okay, granted, I'm off sometimes down, sometimes up, I'm off, okay? But were they like this, you know, or were they like this? And that's what I need to know, and that's why I've got to take the absolute percent error. So that removes the negatives. When I copy this, I see how close or far I was. On 12 different occasions, we were a lot better, on 6 on all of them. Well, this was really good on 7. We were, you know, kind of off here, really big time off here. You know, okay, you see all that. But the bottom line is, what was the average error for each of these choices, each of these lines or curves? Okay, and that's MAPE, mean absolute percent error. That's what MAPE is, mean absolute percent error. So I'm taking the average of this.
What does mean? What does MAPE mean again?
Mean absolute percent error. Yeah. So that the APE is absolute percent error, and the M is the mean. So of course we would Excel it's average. So we use average. And what we discover, if I can get this without going too far off here, that MAPE, okay, the mean absolute percent error for the linear was 9.68. The average error was just under 10%. Okay. The lower the error, the better. Okay. The average error for the power was just under 6%. For the exponential, just over 6%. This reconfirms everything we saw when we were looking at it and when we were looking at our squares. You know, this one was definitely more off than these two, which were closer to each other.